Hi everyone! Welcome to the second video regarding work life. In this video, I'm going to highlight one feature of the recent trend for the Cambridge exams. So the recent trend in this case is that there is a tendency for the Cambridge to actually come out questions which involve including the units, especially in calculation questions. So let's go through the first question, which is actually from IGCSE 06-5, paper 31, May-June 2023. Okay, so for the first question, it says that the staples are made from a block of metal. The mass of a block is 296 grams and the volume of the block is 33.2 cubic centimeters. They ask you to calculate what is the density of the metal and include the unit. Okay, so notice the answer space they actually give the density of a metal followed by a special answer space for the units. Okay, so what you need to do in this case is you need to split the numerical calculation and the unit separately. Okay, so now let's go through the numerical calculation. So you know that density equals to mass over volume. Then you substitute in the values for the mass and the volume. 296 divided by 33.2. And then you punch in calculator and you have the answer. Okay. But how do we settle the units? Okay. So in this case, what we do is we actually indicate the units for density. We put them in square brackets to indicate units for a particular quantity. Is equals to the units of mass over volume is equals to the units of mass divided by your units of volume. So we know that the units for mass is gram and the units for volume is cubic centimeters. So we sub them in and we have gram cm to the power minus 3, or you can write as gram per cm cube. Okay, so you must be wondering why the units can one form change to another form. Why it can be from gram change to gram per cm cube. Okay, I want to highlight to you the difference between how you manipulate numbers and units. So when it comes to numbers, I want to highlight to you that we have learned 4 operations of numbers: addition, subtraction, multiplication, division. And you can actually use the 4 operations to deal with numbers alone. But when it comes to units, things can go a bit tricky. It is something like manipulating fractions. So for example, when we add 1 over 5 plus 1 over 5, we do not add the numerator and we do not add the denominator together simultaneously. In other words, we do not, because of 1 plus 1 equals to 2 and 5 plus 5 equals to 10, and then we add up in this way. This is a big mistake. Okay, so we can treat the denominator of a fraction like dealing with units and the numerator of a fraction like dealing with a numerical calculations. Okay, so the units can be like the denominator of a fraction, how we usually manipulate them. So similarly, let's say meter per second plus meter per second, you must make sure before adding or subtracting the unit. Okay, when you add and subtract, right, the quantities as we shown below, let's say we subtract 2 meter per second and 1 meter per second. We must make sure that the units which are highlighted in green must be the same. Then we can perform the numerical calculation. And take note that the final answer must be the same as the earlier constituents over here. So we have meter per second minus something meter per second. It gives you something meter per second. Notice the units are the same. The similar thing can be said for addition. Okay. Now when it comes to the multiplication and division, for example, 1 over 5 times 2 over 3, what do? We multiply the numerator together. 1 times 2 is equals to 2. And then for denominator is 5 times 3 give you 15. Notice the denominator actually undergoes multiplication as well. Okay, so the similar thing can be said for division. 1 over 5 divided by 1/3, and we have equals to 1 over 5 times 3, you get 3 over 5. Okay, So I want to highlight to you one case. Okay. For example, if we are given A is equals to 5 cm and B is equals to 10 cm, how do we find the ratio B is equals to A? Okay, so we must also ask yourself whether the B over A, are there any units or not? Okay, so what do is we actually deal with the numerical and the unit calculation differently. So for units calculation, we have 10 over 5. Okay, substitute in our relevant values and we get 10 over 5 equals to 2. And then units wise, unit of B over A is equals to units of B over units of A. Then we substitute in the units for B and A, and we have cm over cm. Okay, so it's not like B over A, the ratio is 10 divided by 5 give you 2 cm. This is a very big mistake. Okay, the unit in this case is not the same where you undergo multiplication or division. Okay, treat the cm like x, like how you simplify algebraic fractions. For example, cm over cm is equals to x over x, you get equals to 1. But you do not write 1 as a unit. The correct method you need to do is you write no units, because the cm and cm cancel out each other. So when you are asked the right answer, you are expected to write the correct numerical answer to 1 mark given and the units no units. Okay, you must specifically write no units if the answer don't have units and the question asks you to write units. Okay, then you're awarded credit. If the units are given, for example, they ask you to write units and there are units, you write down the units. Okay, so this is in case when the Cambridge question comes out, especially those that involve no units, you must specifically write no units in your answer. So this is a mark scheme from Cambridge. Okay, usually such questions will carry at least 2 marks. So usually 1 mark will go to the correct units and the remaining marks will go to the correct numerical calculation. So if you notice, the units they give an independent of method marks, 1 mark over here, B1. Then for the numerical calculation, they have A mark, which is answer mark, and C is a calculation mark. Okay. Okay, now let's go through the second question. So the second question is actually from IGCSE 0625, paper 31, February or March 2023, question 1C. Okay, so this question is talking about a cyclist that travels along a straight road, and the figure 1.1 shows the speed time graph of a cyclist. This graph is divided in 4 sections labeled P, Q, R, and S. So this question is talking about the cyclist that move north along a road, and the question asks you to determine the velocity of a cyclist at time is equal to 300 seconds, include the unit. So the answer space, they give you velocity of cyclist equals to blank 2 marks. Okay. So in this case, this may seem like a very straightforward question, but a lot of candidates, I'm pretty sure they fail to get full credit for this. In fact, quite a lot of candidates actually lost marks from this question. So you need to ask yourself, what is the objective of this question? So given that the graph, they only shows the speed and they ask you for velocity, you will need to know that this question is actually testing you on the difference between speed and velocity. So what's the difference between speed and velocity? Okay, speed, by the way, is a scalar which comprises only of a magnitude. Velocity, by the way, is a vector that comprises both magnitude and direction. Okay, so the thing is that you have 2 parts of a question answer, magnitude and direction, to get the velocity for cyclists. So for the speed, notice that from a graph, you will notice that you get 12 meters per second. How? 300 seconds, look at it over here, then you trace all the way up to where the graph intersects with 300 seconds, and we notice that at hour, the speed is 12 meters per second. Okay? So notice that the speed in this case is 12 meters per second, and we have the units over here. I want to highlight to you that the unit for velocity is the same for the unit for speed, and generally speaking, the unit for a vector is the same as the unit for scalar. Okay. So now we already settled with a magnitude, and if you write 12 meters per second, you will get 1 mark. But how do you get the other mark for direction? You need to refer back to the question. So the question says the cyclist is moving north along a road. So in this question, what is the direction of the cyclist's motion? In this case, it's north, right? So you just need to write direction is north, then you get another mark. Okay, so the answer split into 2 parts. Velocity is equal to 12 meters per second, that is the magnitude part, and north is actually the direction part. So we need to have both magnitude and direction to get the full credit for a question that's asking for vector, in this case velocity. So with that, we have come to the end of this video. If you like my video, do remember to like and subscribe to my YouTube channel. Don't forget to press the bell button so that you won't miss any important updates. Will my next adventure be at home or away, and I will see you in the next video. Bye bye.